Okay, hi. Let's take a closer look how to add a TX8 module for serial port communication. In our case, we would use this TX4 to send data to computer. Most of the computers, however, don't anymore have the serial ports. So what we will be doing, we would actually use this CY8C0 kit 059, which is PSoC 5 board as the USB bridge. Okay, I'll go through the design roughly, the fundamentals of design really in a rough way. Okay, first I started the PSoC designer with a scratch. Then I will take their TX8 module, which is basically 8-bit serial transmitter module. First, we need to figure out on the parameters the bit rate. On the data sheet of the module, actually the clock rate is defined right here, and there are a couple of nice examples how to do it. For example, here, if you want the 9600 kilobits per second at 24 megahertz system clock, then you can use either of these settings. Let's take, for example, the first setting. So clock divider for sys clock 1 is 8, and then the see how does it go. VC3 source is VC1, and the divider is 39. Okay, I think I remember those. So VC clock source is VC1, and the divider here 39. This gives close enough signal, clock signal for that module. Then we just need to set the clock to as VC3. Okay, the bit rate actually is always the clock rate that comes to that module divided by 8. Because of the synchronization reasons, the input clock rate for this module must be 8 times faster than the transmission clock rate. Okay, next, the output. Let me blow it a little bit bigger. Usually I start designing the output by selecting the pin, since that's usually the restriction. We have selected some pin to be the output for the serial transmission, and just for example, I could use the port 1.3 and call that one to TX, and not anymore standard CPU clock, but we take it from the global out odd 3, and not anymore high Z analog, but strong signal. So this is driving the next stage. The next stage from this one would be this one. So we are designing for PSoC 1, running a signal to a PSoC 1 pin, and then basically use the this USB UART bridge or USB serial bridge, which is on the programmer half of the PSoC 5 evaluation board. Okay, so strong drive, disable interrupts. We don't want to do pin interrupt here. We might want to do a transmission module based interrupt, but not from the pin. Okay. Next one, where you can connect that one. So basically that would be, let's see, that's Pro 0, output 0, row 0 pin 3 can be connected there. That was that line, I think. Yep. Now we have a connection from this one to here, and then we just click the output of this TX8 module to row output 3. Okay, there. Now we have routed the data transmission signal to port 1.3. Then next parameters would be when that transmitter module should set an interrupt, if it sets an interrupt or request an interrupt. I would say it could interrupt when the previous transmission is completed. Okay, so transmission complete would trigger an interrupt, which means that basically you can make a series of data transmission, for example, sending a string byte by byte on an interrupt service routine. Okay, then the clock sync, as usual, use sync to sysclock unless it says something else on the datasheet. Data clock out, none. So basically, the same module can be also used for synchronized data transmission, but currently in here we are using the async. The RS-232 kind of data transmission is asynchronous transmission. Okay, that's all what you not need to do on this chip design level. Now we generate the application, and again go to the main and start coding. Good place to start again would be from the datasheet. Go to the example. Maybe maybe trying just sending one single byte at first to see if it's working. Make a sleep timer and make this one send, for example, a character. Well, yeah, character A, which is I think decimal 64, something like that. I don't remember it anymore. So that's how you make the system to work. So again, you need to remember, of course, to start with TX8. Oops, not that one. TX8, and no parity there. So the parity setting is done on the start function start or module start. Okay, and so on. And so on, whatever code you put there. Yeah, and then about the connections. So this is the PSoC 1 board. PSoC 1 board. Let me first go to the CAM only. Okay, PSoC 1 board. And then you take a couple of wires. For example, here I have brown wire and red wire to be used. Okay, brown wire I will connect to ground. There are several places you can connect it to ground. Okay, there you go. And the red wire goes to whatever pin you used for the design. And in this case, let me go to that pin out. My transmission is actually on 1.3. That's the transmission pin. Okay, on this board, you need to connect, of course, the ground wire to ground. Make sure that you do the connections without power, and you might otherwise destroy something. And then this actually goes to funny pins since it's transmission here. So only here for some reason is the RX. So the signaling on this board is actually showing what it looks like in the computer end. Okay, so that's the correct kind of wiring. Oops, you cannot see it, not there. Okay, there you go. Not the, so that's the ground pin, and that's second from the right on this view. Actually is the pin where you should connect your transmission. And basically, if you did everything right, including the bitrate calculations, starting your modules, then you should basically see a COM port on your computer. So this shows up as a COM port. I'll show you. So let's take a look at the COM port. So if I plug this one into my computer, oops, that wasn't right. Okay. I lost the picture at some for a minute. So if you plug in that device, then let me take a quick look on the what it looks like on computer. So if you open the device manager, on the control panel, there we go. Your kit prog should show up as a COM port on your computer. And basically it has all the COM port parameters as any physical COM port actually would have. For some reason I lost that. Okay, let's take a look. Okay, port settings. So it has a bits per second setting and data bits, parity, stop bits, flow control. Everything is there. Okay, so this simple device actually works. In our case, we are just using it as a using this only as the USB to serial bridge. Okay, that's all the bits and pieces. Now you just need to work on the exercise to actually have the hands-on experience how everything is done. Okay, that's for this part. Thank you.